Resistors are fundamental components in electrical circuits. They are like tiny control valves for electricity. When electricity flows through a resistor, it encounters resistance. This resistance helps to regulate the flow of electrical current. Imagine a garden hose with a nozzle. The nozzle restricts the water flow. Resistors act similarly, controlling the flow of electrons. Resistors are passive components, meaning they don't produce energy. Instead, they manage the flow of energy in a circuit. This control is essential for the proper functioning of electronic devices. Resistors are found in almost every electronic device, from smartphones to spacecraft. They play a crucial role in our technology-driven world. Resistance is the opposition to the flow of electrical current. It's measured in ohms, symbolized by the Greek letter omega. The higher the resistance, the more the resistor restricts current flow. Think of a narrow pipe versus a wide pipe. Water flows more easily through the wide pipe. Similarly, electrical current flows more easily through a low-resistance path. Resistors introduce controlled resistance into circuits. This resistance is essential for various reasons. Resistors can limit current, divide voltage, and even generate heat. Without resistors, electrical circuits would be chaotic. Components might receive too much current and get damaged. Resistors ensure that the right amount of current reaches each part of a circuit. Fixed resistors have a constant resistance value that cannot be changed. They are fundamental components in electronic circuits, providing a predictable and stable resistance that is crucial for the proper functioning of various devices. They are the most common type of resistor, found in almost every electronic device you can think of, from simple gadgets to complex machinery. Fixed resistors are color-coded, with each color band representing a digit or multiplier. This color-coding system allows for easy identification of the resistor's value, making it simple for engineers and hobbyists alike to use them in their projects. These resistors are used in countless applications, from limiting current flow to dividing voltages. Their versatility makes them indispensable in the world of electronics. For example, they limit current to LEDs, preventing them from burning out. Without the right resistor, an LED could receive too much current and be damaged. They also help set the operating point of transistors, which are crucial for amplification. By providing the correct biasing, fixed resistors ensure that transistors operate efficiently and effectively. Fixed resistors come in various sizes and power ratings. This variety allows them to be used in different environments and applications, from tiny portable devices to large industrial machines. The size and rating depend on the amount of power the resistor needs to handle. High-power resistors are designed to dissipate more heat, making them suitable for demanding applications. Choosing the right resistor is essential for circuit reliability. An incorrect resistor can lead to circuit failure or even damage other components. From simple circuits to complex electronic devices, fixed resistors are indispensable components that ensure proper circuit operation. Their reliability and versatility make them the workhorses of the electronics world. Variable resistors, as their name suggests, allow us to change the resistance value. This variability makes them essential for controlling things like volume, brightness, and speed. One common type is the potentiometer, often used as volume knobs in audio equipment. By turning the knob, we adjust the resistance, which in turn controls the sound level. Another type is the rheostat, often used to control motor speed. By varying the resistance, we can regulate the amount of current flowing to the motor, thus controlling its speed. Variable resistors provide dynamic control, allowing us to fine-tune circuits for specific needs. This flexibility makes them invaluable in many applications. Section 5. Thermistors and Resistors, environmentally aware resistors. Thermistors and Resistors are special types of resistors that change their resistance based on external factors. Thermistors are temperature sensitive, while Resistors respond to voltage changes. Thermistors are used in temperature sensors such as those found in digital thermometers. As the temperature changes, the resistance of the thermistor changes, allowing us to measure the temperature electronically. Varistors, on the other hand, protect circuits from voltage spikes. When a surge occurs, the varistor's resistance drops dramatically, diverting the excess voltage away from sensitive components. These specialized resistors provide valuable functionality, enabling us to create circuits that respond to environmental changes and protect against potentially damaging events. Section 6. Resistors in action: practical applications. Resistors are found in virtually every electronic device we use daily. They are the unsung heroes that ensure our gadgets function smoothly and efficiently. In computers, they help regulate data flow and power distribution. Without resistors, our computers would overheat and malfunction, leading to potential data loss and hardware damage. In smartphones, they control screen brightness, audio output, and battery charging. This ensures that our phones are not only functional but also safe to use. Household appliances also rely heavily on resistors. From your coffee maker to your refrigerator, resistors are at work behind the scenes. They control the heating elements in ovens and toasters, ensuring that your food is cooked evenly and safely. The motor speed in washing machines is regulated by resistors, allowing for different wash cycles and protecting the motor from damage. And the timing functions in microwave ovens are also managed by resistors, ensuring your food is heated just right. Resistors are essential for LED lighting. They limit the current flowing through LEDs, preventing them from overheating and ensuring their longevity. Without resistors, LEDs would burn out quickly, making them inefficient and costly to replace. From complex medical equipment to simple toys, resistors play a crucial role in making our technology work. They ensure that devices operate within safe parameters. Resistors are fundamental components in electronic circuits, providing stability and reliability. Their ubiquity highlights their importance in modern electronics. Without them, our world of technology would be vastly different and far less reliable. Section 7. Understanding current and voltage with resistors. Resistors help us understand the relationship between current, voltage, and resistance. They are fundamental components in almost every electronic device, from the simplest gadgets to the most complex machinery. This relationship is defined by Ohm's law, which states that voltage, V, equals current I, multiplied by resistance, R, V equals Y times R. Ohm's law is a simple yet powerful equation that forms the basis for understanding how electrical circuits operate. This fundamental law shows that if we know any two of the variables, we can calculate the third. For instance, if we know the current flowing through a resistor and its resistance, we can easily determine the voltage across it. For example, if we know the voltage across a resistor and its resistance, we can calculate the current flowing through it. This is particularly useful in designing circuits and ensuring they function correctly. Ohm's law is a cornerstone of electrical engineering. It is taught in introductory courses and remains relevant throughout an engineer's career, helping to solve real-world problems. It helps us analyze circuits, design new devices, and troubleshoot problems. Whether working on a small project or a large-scale system, understanding Ohm's law is crucial. Resistors, therefore, are not just components but also tools for understanding electrical principles. They play a vital role in controlling the flow of current and protecting sensitive components in a circuit. Section 8. Power rating and resistor selection. When selecting resistors for a circuit, considering their power rating is crucial. The power rating indicates the maximum amount of power a resistor can safely dissipate without overheating and getting damaged. Power is calculated using the formula P equals I squared times R, where P is power, I is current, and R is resistance. Choosing a resistor with a power rating higher than the calculated power dissipation is essential. Using a resistor with an insufficient power rating can lead to overheating, failure, and even fire hazards. Always consult data sheets and select resistors with appropriate power ratings for the intended application. Section 9. Conclusion: the unsung heroes of electronics. Resistors may seem like simple components, but their importance in electronics cannot be overstated. They are the unsung heroes that ensure the proper functioning of countless devices. From regulating current and dividing voltage to sensing temperature and protecting circuits, resistors play a diverse and critical role. Their ability to control the flow of electricity makes them essential for our technology-driven world. As we continue to innovate and develop new technologies, resistors will undoubtedly remain essential components, silently and reliably performing their tasks behind the scenes. Their importance will only grow as electronics become increasingly sophisticated.